Hey guys, welcome back to next video of Polkadot education series. Today's video is gonna be in English because in today's video we are gonna be doing an AMA with Gavin Wood, whom if you don't know, Gavin Wood is one of the co-founder of Ethereum. In fact, he wrote the yellow or the technical paper for Ethereum. He was also the first CTO for Ethereum Foundation, and later on he moved on to found Polkadot, which was launched in 2020. Now, it has been 4 years since Polkadot launched, and Gavin Wood recently released a grey paper, which is gonna change the entire ecosystem of Polkadot, how it currently works. So in today's videos, we'll try to talk to Gavin Wood and try to get his perspective on JAM, like what it is, how it works, and how it's gonna change everything on Polkadot. But before we move forward, we would like to disclose this education series has been made possible due to Polkadot Treasury Grant. Hi Gavin, it's a pleasure to have you on the channel. Our community is excited to hear from you and learn more about Polkadot and JAM.
Nice to be here.
Absolutely, Gavin. Before we dive into questions, let's give a quick introduction to our Indian community. There are a lot of people who have recently joined crypto, and it would be a good opportunity for them to know about you and Polkadot. So maybe you can start with a brief introduction about yourself and your journey within crypto.
Sure. My name's Gavin Wood. I started out in crypto late 2013, properly when I was coding the first version of Ethereum and helping in some of its early design work. Well, once Ethereum launched, I left the Ethereum Foundation in late 2015, started Parity, where we continued work on the Ethereum protocol, the Parity Ethereum client, now Open Ethereum, which was a Rust-based implementation. Parity also implemented a couple of other blockchain protocols, Bitcoin and Zcash. And in late 2016, I proposed Polkadot, which is basically the first decentralized sharded chain. And it was done in such a way that the different shards could each be their own blockchain. So this was implemented. We started implementing it in December 2017 and continued right through to launch the sort of initial version of a Polkadot value-bearing testnet canary network, Kusama, in late 2019, and then Polkadot in 2020, finally expanding to Polkadot's Parachains, so it's actual sort of proper service in 2021. JAM is the next iteration of the Polkadot protocol, ratified a few months ago, based on a technical paper that gave it a clear scope and specification, called the Grey Paper. And we are currently at a period of heavy development, prototyping and implementing the first version of JAM.
Nice, yeah. We have quite a lot of questions about JAM. It's a little complicated, but I guess you are the best person to answer all the questions. It's been 6 years since Polkadot was formed. So, in crypto, everything moves really fast and there are multiple innovations. There's a lot of adoption. So how your vision has changed from that time till today?
Not much, truth be told. But I think the one change I would point to is that when I wrote the Polkadot original Polkadot vision paper in late 2016, it was really centered around what I called a heterogeneous scalable multi-chain, which is essentially multiple blockchains, all sort of tied together under the same security umbrella. And the idea was to sort of make shards, which were at least at that point assumed to be the way that we scale blockchains, but make the shards be each individual blockchains, each doing their own thing, and as it happens with Polkadot, having their own team behind, doing their own sort of token issuance and so forth. And this is one way. It's a very opinionated way of building a scalable network, and you see other networks that are Ethereum specifically, that takes a still very decentralized mindset, but takes a somewhat different approach. And although it must be said, their approach is rather skewing now quite a lot towards the original Polkadot product model, which is let's have lots of layer 2 blockchains, each doing their own thing, each with their own team behind, each with their own token. So actually it's starting to look quite a lot like it. But in principle, Ethereum is much more general than that product mindset. And I think my main takeaway having built and launched Polkadot, is that this isn't the only way to scale. It isn't. Having many blockchains all be secured by one token isn't the only way to scale, and this is really where Jam comes in. Jam is a more. It takes a lot of the work that we've done with Polkadot, but it builds a more general system that can handle more types of services than blockchain. Blockchain is one kind of decentralized, trust-free digital service. But we can imagine other ones, smart contracts, for example. And Jam facilitates actually using the Polkadot block space, the security, the thing that the token actually underwrites, with other services, not merely securing a blockchain.
So what that means is, right now we have Relay Chain, the Polkadot chain, which is the main chain. But after Jam launches, Jam will become the main chain, which will have different services. One of those services is going to be Polkadot Relay Chain, which will have Parachains on top. Is that correct?
That's right. So what Polkadot currently does, so what the DOT token, the facility that the DOT token can be used to pay for, is a utility token, right? So the utility that the DOT token is used to pay for is what we call block space. But more specifically, it's block space that is quite heavily tailored around securing a blockchain, right? And we see many of these blockchains. We call them parachains in Polkadot. Moonbeam is an Ethereum compatible parachain, right? That Polkadot is securing. There are many others that I could name. Now these blockchains, they're isolated, right? They can send messages to each other through Polkadot, but the messages take a little time to arrive. I don't know, like 30 seconds or something to get back and forth. And they have to be quite small. Now, this leads to a potentially quite fragmented ecosystem, because all the blockchains are sort of quite independent, quite isolated. Not wholly isolated, but quite isolated. More isolated than, say, smart contracts that sit under the same smart contract environment. And this is a problem of blockchain, of having this blockchain building block that we use, that we kind of stamp out as a template, new ones, right? So it's like in Polkadot, if you want to bring in another team, they build a blockchain and deploy it to Polkadot, right? It's not that you can deploy a smart contract directly to Polkadot. So this blockchain securing service is one of the services that Jam can do, right? It's like we call in Polkadot, we call this chain, the main chain, the relay chain, right? In Ethereum, it's called the beacon chain. Different projects call it different things, but it's the main chain. Now, this main chain does a thing. It secures these blockchains, the parachains. What Jam allows is to make this a service and then allow developers, potentially, me, but potentially lots of other people, whoever, it's permissionless, to develop other services, alternative services to this Polkadot One service, like the relay chain service, the service that secures these parachains. We can imagine, sort of maybe a decentralized storage service, something, realistically, they're going to be services that can operate to a large extent individually, like in isolation, but that need a more flexibility and more power than you can attain by just sort of building a blockchain. Blockchains have very particular limitations. Now, I can go into those technical limitations, but the upshot is that essentially blockchains are linear processes. They are they're linear systems. So they run everything in sequence. Like basically, a blockchain has a thing at the beginning of the block, a state. Right. And then there's some stuff that it does, like transaction processing, transfers and so forth. And then it's got a state at the end of the block. And it's like the state is the state of everything, of the world, as far as the blockchain is concerned. And then these transactions happen. And then it's another state, the state of the world. So basically, it insists that it knows everything to do with the world. Then when it applies the transactions, and then it can say everything to do with the world after the transactions. This means it really limits us in terms of parallelization. It limits us in the ability to do other work at the same time, which is really the cornerstone of performance.
So Gavin, you said right now it's not possible to deploy smart contracts on Polkadot Relay Chain. So once JAM launches, will it be possible to have smart contracts on Polkadot Relay Chain, and also on JAM, will it be possible to launch smart contracts?
So when JAM launches, when JAM sort of takes over as the Polkadot protocol, then instead of there being a relay chain, there will be a JAM chain, right? So JAM stands for the join accumulate machine, right? Join and accumulate, the sort of two steps that the machine does. And at that point, what the relay chain used to do, that will be I hesitate to call it a smart contract, because there's a few things it can do that smart contracts can't. And if I call it a smart contract, people are going to get confused or misinformed. But a smart contract like thing, call it a smart service, right? Smart service, smart contract like thing. It's like a high performance smart contract. It's like a really, really high performance smart contract, parallelizable, all sorts of things. So it's like kind of high performance smart contract, smart service, of which the relay chain, that'll be one of these services, smart contract like things that sits on the JAM chain. But there will be, anyone can deploy another or as many other smart contract things, smart services, high performance smart contracts onto the JAM chain, right? So it's like the JAM chain becomes a chain. It's not a smart contract chain, because it's not a, if you look into the technical details, the specific product details, you'll find that it doesn't do some things you might expect of a smart contract, and it can do lots of other things that you wouldn't expect of a smart contract. So it's not a smart contract chain per se, but it's got some similarities to smart contract chains. One of the similarities is that you can deploy code onto it, just like you deploy a smart contract onto a smart contract chain, and it will run sort of autonomously. You don't have to have any, blockchain nodes or parachain nodes or collator nodes or validator nodes or any of this. You don't have to run a blockchain. You can deploy code and it will sit autonomously on the JAM chain. So in that sense, yes, it's permissionless. You can deploy code to it, but the nature of the code that we're deploying is somewhat different to smart contract platforms like Ethereum, right?
So this is very important. If we just call it smart contract, then it doesn't do justice. It's completely different. So can you explain the difference of what it can do, which a smart contract cannot do?
Yeah, so okay. JAM is the services that sit on JAM are a little bit, as I say, they're a little bit like smart contracts. There's a few things that are different. So one of them is the service has two different pieces of code, right? The pieces of code work together, but instead of there being one piece of code that smart contracts have, a service has two pieces of code. One of them executes on-chain, more or less similar to what smart contracts do at the moment, but the other one executes off-chain, executes in a concept, what we call in-core, right? JAM has a lot of cores. In fact, it has 341 cores in its current specification. So 341 cores. You can think of cores a little bit like CPU cores, right? So like discrete elements that can do computation on it in parallel with each other.
But this can change, yeah? The number of cores can change? Okay.
In principle, it's related to the validators, the number of validators. And if the validators can get higher, then the cores can get higher. Probably it will scale with silicon. So as silicon gets faster and able to do more and so forth, then you can scale the number of cores. Okay. So we have the concept of an in-core piece of computation. Now, the in-core piece of computation can execute code just like the on-chain smart contract-like piece of computation, but it can do it a lot faster, and it can do it in parallel to all of the other cores, all the other in-core code that is executing at the time. This has significant repercussions. So one of them is, unlike on-chain code, it can't touch the state of the chain, but what it can do is look into what we call a data lake, a decentralized or distributed data lake. Basically, this is like 2 petabytes of data that is a database that's like 2 petabytes big that the cores can read and write from. Yeah, so it's like a huge decentralized hard disk, and the cores can read and write from the hard disk. Now, there are some synchronization caveats that mean If you want to do something and be certain that it has happened and that nothing else could do something that is contravening that, then it has to happen on chain. It has to happen in the on chain part of the state change. But if we're just talking about large amounts of data and you need to sort of do some computation on some large amount of data, and then sort of maybe there's some result that you want to take out and then pass onto the chain, you can do that in core. Now, in core computation has the same security guarantees as the on-chain computation, which is to say it's trustless, it's trust-free. It's just so much faster and has access to so much more data. And this is one of the key elements that differentiate these services from smart contracts. Just the mind-bogglingly large amount of computational resources that services have in this first step, this in-core step. Then they have the on-chain step, and then these two things can kind of talk to each other. It's sort of one-directional, but they can kind of talk back if it goes. Again, some technical caveats. But basically, these two things talk to each other, but they each have different there are sort of different reasons that you'd put code in each one. Now, one of the other things that I want to bring up here is that because of this, it doesn't really make sense to have transactions be the basic amount that you pay for. So if you go to Ethereum, people pay for transactions, right? There's a gas price. Right. Transactions have some sort of gas, and you work out how much gas it needs, and you put a gas price and you multiply them together, and you pay that money. The transactor pays. In JAM, doing it always this way would basically mean that we couldn't do parachains the way that we're doing parachains at the moment, which is where parachain teams can buy a month of blockchain time, of block space, right? We in Polkadot, we kind of JAM, we call it core time, but core time, block space, basically the same thing. Now, as I say, in Polkadot, we can buy core time or block space in 1 month segments, and this happens at an auction. Right, so you basically pay the chain. The chain burns the tokens for this. So we have this ability to buy a lot at once. Now, you couldn't imagine that in Ethereum, right? You wouldn't buy a month of Ethereum at once. That would be crazy, because you basically stop anyone else using Ethereum. We can do it in JAM because we have so many cores. We have 341 cores, so we can actually say, if you want, you can buy a whole core for a month, like 1/341th of the JAM computational. Now, I suppose you could do this sort of in Ethereum if you sort of split the gas up into like 300ths of a block, and then you could sell them off. But anyway, it doesn't really make sense. The transactional model makes much more sense because people are doing so little with each transaction. In JAM, people are doing so much, and therefore it makes much more sense to auction it off in bigger chunks, bigger amounts, so that you can do more things with them. And this so this model is how JAM works. And what we sort of say is it's agile core time, right? It's agile, but it's in JAM we can essentially specify. We kind of do the, how can I put this? We do the gas payment separately to the work specification. So in Ethereum, you pay your money as you specify what it is that you want to be done on Ethereum, right? The transaction does both. It both makes your payment and says what it is that you want to use the gas for. In JAM, it's split apart so that we can open up all sorts of different possibilities. So you make the payment for core time or block space, potentially for a month at a time. And then what that does is it allows you at some later stage to specify what it is that you want done with it. You don't have to specify ahead of time. You can, for example, sell it on a secondary market first, trade it around, split it up into pieces, split it up into sort of interleaved sort of pieces. And then sell each of those, or split them up further, or interleave them further, right? And only when you're ready, when it gets to its sort of final customer, do you then, before you use it, have to specify what it is that you want it to be used for. And it might be, it's like you might just say, well, look, here's my public key. Anything I sign, use it for that. But you might also say, well, it's this Parachain 42. Any block that is valid for Parachain 42, use it for that. And this could be a small computer program. It's like a smart contract in itself. A smart contract just to specify how this gas, so to speak, that you've purchased, core time, block space that you've purchased, how it's allowed to be used. And these two things together kind of are sort of the two sort of really big changes, or distinguishing features from a smart contract. There were others that I could go into. I could go into this for a couple of hours.
Yeah, but
like
this what you described,
these are the two
it's like
biggest.
smart contract on steroids. Like it can do like infinite amount of computation.
Well, infinite's a big number, right? But
Yeah.
I think we're looking at about 1 million X on
Okay.
sort of Ethereum taken as an L1, right? So if we disregard the sort of L2 scaling quote unquote solutions, then our current models show that we should be able to achieve around about 1 million X on that.
Okay. That's quite interesting. Didn't read that. I mean, you explained it pretty well.
So Gavin, you mentioned like on Jam, there are going to be different services. One of the services is going to be the Polkadot ecosystem that we have, the relay chain with Parachains and everything. It's going to be one service on Jam. So can you let us know about like what sort of other services can come onto Jam, or are there other services that you are thinking about? Like if you can share your views on that.
Yeah. So I mentioned potentially some sort of decentralized storage service. Now this would work in concert with this decentralized distributed data lake, right? So this like huge, like 2 petabyte database that is available for use by smart contract services, right? Jam services. And the idea would be that if you would be able to mark data that is in this data lake, and have it be stored sort of separately to the data lake. So the data lake can't store all data 2 petabytes it can't store data indefinitely. Otherwise the 2 petabytes would be exhausted and then no one would be able to store anything, right? So it stores 2 petabytes in its stable state as a maximum, but in its stable state. And then data actually sits around for a month, so 28 days or whatever. And then after 28 days, unless that data is reinserted, then it drops out. Now, you might be that you want some data to sit in it forever and you're willing to pay, right? You just want the data to sit in forever. We can imagine a decentralized storage solution that would be willing to take the money and do that. Now, it could be implemented as like a blockchain or a smart contract or whatever, but it may very well be much more convenient if it's implemented as a service and it sits really at the lowest level of Jam, or well, the lowest user level of Jam. One other very interesting possibility, and this is something that really drove Jam forward, is the possibility of hosting smart contracts directly on Jam, or maybe not directly. Okay, directly on Jam is maybe pushing it a little because it wouldn't be part of the core protocol, but on something that is not a blockchain, right? On Jam. So on something that is more directly on Jam. And this, we can imagine a service that would avoid. So here is the big, I'll go into like the big issue, right? With blockchain scaling solutions at present. They basically are either insecure or they are based on hardware being faster. Just validator hardware being faster isn't resilient, isn't Web3. Or they're based on essentially having linear systems like blockchains, so very serial systems, like lots of different threads, lots of different shards, all doing their thing, and securing them each under the same umbrella. This is what Ethereum does with its L2s, right? So it has the Arbitrum L2, the Optimism L2, the ZK EVM L2, and so forth, right? And it's got these different L2s, and they're each like mini Ethereums, right? They're each like mini Ethereum L1s. You can deploy smart contracts. They're kind of secure, and if you wait for long enough, you can communicate between them. But if you deploy a smart contract to one, you can't deploy a smart contract to the other. You can, but it'll be a copy of that in a different environment, right? It's not going to be the same thing. And this is the problem. It's a similar problem to what we've come up against in Polkadot, which is that Parachains are their own thing, their own teams. They run in a relatively isolated environment. This is just a natural problem with sharding. If you shard, like you shard databases, it implies that data lives in one shard or another shard. It can't live in both, and it can't evenly just move between them both, right? It kind of lives there, and it has some. It's kind of like a farmer lives at a farm. You can't uproot the farmer very easily to another farm. They'll get upset. They won't know where the tools are. They won't know how to work the fields and so forth. Right? It's like these things live on their shard. You can't uproot them very easily. So wouldn't it be nice if we could have that parallelism, have that scalability, that performance, but yet not have to force teams to deploy into one particular scaling solution, one particular L2 or another L2, one particular parachain or another parachain? Wouldn't it be nice if we didn't have to choose? Yeah, that's how you build a scaled, performant, ecosystem-wide solution. And this is really where JAM comes in. What we want to do with the JAM service ultimately is provide this kind of thing. A platform that is ultra scalable, right? Where we can still use this huge amount of computation power, but where the teams, the application teams, the product teams that are deploying their smart contracts or computer programs, really, right, into the system don't have to choose whether they want to go on the Moonbeam Parachain or the Arbitrum Ethereum L2 or the Optimism L2 or this or that or the other. And in doing so, not be able to interact very well with all of the other things, all the other places that they could have deployed. This is what we really want to build. Something where instead of having to choose the home and like an office worker having to choose the company that they work at, instead the ability to work from anywhere, pick any cafe, right? This kind of ability to be free and move around and be just paired up with the other smart contracts that you happen to want to deal with right now, not be forced into a specific platform with only those smart contracts that happen to also be on that platform.
So they are basically deploying directly on JAM. So if I write a smart contract, it will be deployed directly on JAM or some other service which will be on top of JAM.
So it can't be JAM itself, because of course JAM doesn't have smart contracts; it only has the services, right? But it would be a service that sits on JAM that hosts smart contracts, but hosts smart contracts sort of in JAM. And I hesitate even to say smart contracts now, because these would be so incredibly powerful. Like they'd have so much compute power behind them, so much ability to store data. Really what we're talking about is just software. It's just computer programs, but they would have all of the benefits of smart contracts, the trust, the freedom from trust, right? The ability, the permissionlessness. They would have all of this stuff, but they would be like smart contracts, except a million times faster and a million times more storage available and a million times, it's like, but when you get this level of speed up and this level of more information, more data that can be stored, and this level more accessibility due to its reduction in cost, it doesn't make it's like it's a materially different product. So sort of doesn't really even make sense to call these things smart contracts. But yes, they would have they would have the good things about smart contracts. They just wouldn't have the drawbacks of smart contracts, which is like, that they're costly, that they have to happen in series, in this kind of linear format, that they have a limited environment.
What if any of the Polkadot parachains want to migrate to other services that come on top of JAM? Is it possible?
Easy. Yeah, totally. I mean, so parachains at the end of the day are blockchains. They're substrate blockchains, right? We've seen parachains that have moved from one relay chain to another. Parachains that have started off not having a relay chain and have been moved like just a solo chain, just a regular blockchain, and have become a parachain. It's not they're not tied down particularly, right? In reality, the difference between a parachain and a regular substrate blockchain is minimal, right? They are just regular substrate blockchains. The only difference is that they have a little bit of extra code that sits on chain and a little some extra code that sort of sits in the validator nodes, collator nodes, that basically allows them to know when they've been filed, to submit themselves as candidates for finality to the relay chain, and to know when the relay chain has finalized them. So instead of using grandpa as a finality gadget, which is like our sort of bootstrapping finality gadget that can work regardless of any other blockchains, they use a relay chain as their finality gadget. But this is the only difference, and it's a relatively minor one. Which is why we totally expect to just move Parachains over from the relay chain to a service on Jam, right? A service on the Jam chain. And in principle, they don't need to be moved over to the Jam chain service. They could be moved over to or to that Jam chain service. They could, in principle, be moved over to some other Jam chain service. That's not a big deal. And similarly, once they're on once they've been moved over to the Jam chain service, they might want to move themselves to some other service at some later stage. There's nothing technically speaking that is problematic for this. The code just needs to be written. If someone wants to write it, then it's pretty easy.
So any of the services that will come on Jam, they can have their own token? They can choose to have their token or no?
Sure, if they want. I mean, it's code. It's totally arbitrary code. It can do what it wants, just like a smart contract, just like when you're writing a computer program on your own laptop.
So on Jam chain, are there going to be any transactions that are going to get executed, or it's just going to power all the services?
No, Jam chain is actually transactionless. There's no way of placing a transaction on the Jam chain. It doesn't have any possibility for users to make transactions. Everything happens in Jam services, and in fact, for several of the important system services, like the sales of core time of like Jam's gas and validate and nominating and validating staking, these will sit on blockchains that sit on the relay chain service that sit on Jam, right? So if you want to, it's a little bit like you could call it an L3, but I mean, it's kind of an L3 because it's a parachain that sits on a service that sits on Jam. Jam is sort of the L1. The service is, I mean, you could maybe say the service is still the L1, I guess. Maybe you could just call it an L2. But yeah, it's not going to sit in Jam directly. Jam can't handle transactions. It's designed not to have to handle transactions. It's designed to be super, super simple and super, super unopinionated. Like, it's as simple as it can be for doing this highly parallelized, high performance, smart service Jam service host. And this is it. And when I was writing the Jam paper, I would huge amounts are borrowed from Polkadot, right? Some of the terminology is different, some of the design is different, legitimately, but a lot of the underlying security elements, which has now been published in a separate paper called ELVES, ELVES, linked to from the grey paper.
We had that in notes.
Okay, cool. These are they're largely unchanged from Polkadot. What Jam does is actually it removes probably more logic from Polkadot than it puts in. Right? I would hope it removes more. I'm pretty sure it removes more logic from Polkadot than what it puts in. It's sort of like half of Polkadot. It's just sort of the lower level half. The higher level half, all the stuff that deals with parachains, that would sit in the relay chain service. That is user code, right? It's like a permissionless smart contract, smart service thing that sits on Jam that we deploy onto Jam, but it's not Jam itself. Jam doesn't have transactions. Jam doesn't host blockchains. Jam doesn't host smart contracts. really. It hosts these funny things, these sort of dual code things called JAM services.
So Gavin, let's talk about Polkadot Toaster. I saw recently you tweeted a picture of the toaster. So can you please tell us more about this toaster and how it's gonna power Jam?
So the JAM Toaster is a I don't know what we call it really. It's a big computer. I mean, it's nothing like what, it's nothing like as big as modern supercomputers that, have, God, like 10,000, 100,000 GPUs, right? I don't know how many GPUs they put in now. It's a lot. So we're not anywhere close to that level of performance. But it's about, I think it's got 16,000 CPUs, right? So it's still a decent, 16,000 CPU cores, right? But they're high quality CPU cores. We're not talking about these, piddly little RISC-V or ARM chips that have like 128 cores and only cost a grand or two, right? It's like they're serious cores, the AMD Threadripper, right? 5 gigahertz cores, right? They can do some serious shunt. And this is it's got, I don't know how many, like a bunch of 32 petabyte. I can't remember. I've discussed that. I've got a slide with all of the specs on, but it's got like terabytes of RAM. I think it's got like a few petabytes, no more, exabyte, no, maybe petabytes. I can't remember. Like lots of, I think it's got like several hundred petabytes of storage. It might even be even higher. I can't remember though for sure. And it's got what else? It's got some really hefty networking to bring these different nodes together. So it's a serious performance machine. And the idea is that Jam can, in one machine, in one spot, host the whole of the Jam network, or sort of a version, not the final thing. Obviously, that will be decentralized, lots of different validators and so forth. But a sort of test net. It can host a full-scale test net of Jam, and with and because we can do a sort of full-scale test net, we can do all sorts of nice things, like we can simulate networking outages, we can do investigations into emergent effects. This is one of the things that we always had a lot of problems with Polkadot. When you're working on a test net, either your test nets are going to be quite small, or realistically, they're going to be run by other people. And other people tend not to be so good at like putting on all the correct debug flags or having all the right monitoring stuff. Or if they do have the monitoring logs, maybe they didn't have the right options, or maybe they did have the right options, but then they can't remember where the logs were for that particular date and time and second, right? And it becomes very quickly very difficult to diagnose emergent issues, especially when we're talking about 1,000 different computers, right? 1,000 different nodes. So what the purpose of the toaster is to host everything in one place under known, very controlled environmental conditions, and be able to identify emergent problems and be able to do optimizations, like really sort of solid network level optimizations, not like optimizing a code base to make one particular benchmark go faster, but optimizing a decentralized 1,000 node network to ensure that it's not the case that sometimes it takes 18 seconds to produce a block, a parachain block, or to make sure that sometimes just a transaction doesn't make it through into a work packet and through into the system. There are sort of emergent effects that you get when you have this number of nodes, each operating independently of each other. And the ability to observe in a very deep fashion is, I think, very important to be able to understand these effects and correct them.
So once we move forward from the testnet and when everything is tested, will we be able to buy Toaster and like to be part of Jam, or?
I mean, the toaster's quite expensive. I'm not sure if they'd be able to buy the toaster. No, but I mean, we're talking about 1,000 nodes. Like it's
Okay.
I think the cost stretches into the million. So no.
So these will be data centers probably, or the validate or big validators.
Oh yeah, I mean the toaster is being built and will be hosted at the Polkadot. What is tongue in cheek called the Polkadot Palace, a large villa in Portugal, just outside of Lisbon, and it happens to have a pool that will serve as a very nice heat sink reservoir for the toaster. You got to put that heat somewhere. So we so the toaster is going to be sort of built there. It will be in one place. It'll be hosted with a small team, and the toaster will be provided to teams that are at the stage where they are looking for there's these sort of structural optimizations for their clients, and also looking to see how their implementations of JAM interact with other implementations of JAM. What sort of effects might happen. And honestly, this is really interesting stuff. It's a little bit like when you introduce a new species into a biological ecosystem, and you don't know exactly what's going to happen. Are they going to eat too many of this ant, or are they going to get preyed upon by this bird? And it's like, how is it going to alter the ecosystem? You don't know. Yeah. And so what we'll probably end up doing is like saying, right, well, when you're at the stage where you can actually be a node, we'll put one or two nodes onto the JAM network and start you in the into the JAM Toaster sort of network, start you in the rotation. And so of these 1,023 nodes that the JAM Toaster is hosting in its 16,000 cores, it will be able to sort of deploy some implementations, some other implementations, and I mean, at the moment we have like 23, I think, implementation teams, each making an implementation of JAM. Right. Now, some of these probably are never going to go very fast or get to the final stage, but I would hope many will. And we need to be able to test all of these in an environment and work out, like, if things start going slow when a quarter of them are this implementation, then we need to know why is that happening? Is it something wrong with this implementation, or is it something wrong with that implementation? Because the problem is implementations have to be correct, and they have to be sort of fast as far as we can tell. But when you're talking about 1,000 different sort of actors, 1,000 different nodes, maybe that the emergent effect isn't incorrect, but it is slow, or it's volatile, or it doesn't, it sort of stops every now and again, and we need to know why. Right, and we need to know whose fault it is, but we also need to fix it so that the network, the production network, has as many different implementations as possible, and not that just everyone goes for one implementation because they know that it's the one that has the least bugs or the one that is the fastest or whatever. We need to make sure that they're all at a good standard, and this means several things, but one of which is mixing them up, putting them into this environment, and making sure that the overall emergent effect of the JAM network is that it keeps going. And we do this through the JAM Toaster in large part.
Nice.
So Gavin, I saw you talk about Cynical Rollups. Can you please explain what is Cynical Rollup and how does it differ from ZK Rollups?
Cynical Rollups are the basis of both Polkadot and JAM. They're how both these networks scale. So we have a few different types of rollups in the world, right? We have optimistic rollups, we have ZK rollups, and now we have cynical rollups. ZK rollups are essentially utilize the fact that a particular technology called snarks and starks. They're more these days, they're sort of a little bit merged anyway. People use Stark, sometimes they mean Snark, sometimes they mean Stark. It's kind of interchangeable, but at a conversational level. And these pieces of technology, roughly called zero knowledge technology, are used for the fact that it is, generally speaking, quite a lot faster to verify that some particular piece of computation was done correctly than it is to generate the proof that can be verified, right? So you can sort of generate a proof that you did some computation correctly, and this is the result, one presumes. And that can take a long time. And when we say a long time, what we really mean is costly. And then it's a lot less costly, takes a lot less time, a lot less costly to verify that proof, verify that the proof is indeed a proof that that particular computation was done correctly and resulted in this answer. It's like checking the results, checking the work is faster than doing the work, sort of, except they don't necessarily even do the work, but they generate a proof that can be checked. So this basic proposition is the argument behind why ZK rollups are good. Now, the problem with ZK rollups isn't really that proposition. The problem with ZK rollups is that the costs involved are huge. Now, there's an argument that the costs are going to go down, and it's like probably true. They probably will eventually go down. No one can say what the floor will be, and there probably will be a floor because in practical things there usually is. But you know, the reality, the trajectory is certainly downwards, right? The question is, where does it land, and when will it land? And at the moment, there is no great reason to believe it's going to land very low anytime soon. And so, as a developer, as an engineering team, or as a protocol engineer, protocol designer, I'm not going to count on this particular piece of technology as my scaling solution. And I didn't want to count on it 5 years ago, and we didn't. And this is why we came up with Cynical Rollups. And I'm not going to count on it today. And, you know, in 5 years' time, maybe I'll take another look at it and see if it's gotten fast and cheap enough. But honestly, given that the market for GPUs seems to be only getting even more of a seller's market, and given global disruptions to silicon supply chains, it seems unlikely that market is going to get become a buyer's market anytime soon. I can't see this getting sufficiently cheaper for some time to come. So at the moment, our calculations are that it costs about 60 million times more to to generate a proof that some computation was done correctly as it does to just do the computation yourself, right?
Wow.
63 million times more expensive. And that's a lot of times more expensive when we're trying to make things as cheap as possible because we want transactions to be able to be done basically for free. That's a huge amount more expensive. Now, of course, that's you only have to do that proof once, right? I mean, if you're happy with there being just one big centralized prover, you only have to do it once. If you want to have some sort of market, then you're going to have to do it a few times, maybe 5 times, 10 times, depends how many market participants you want. And then beyond that, you still need to verify the proof. And even proof verification is still an order or two of magnitude more expensive than to just do the computation yourself. Which is crazy, right? Why would you use this stuff? It's so expensive. But I mean, at the moment, the reason that people are using it is because, hey, from a mathematician's point of view, this is super sweet. Like, from a mathematician's point of view, this is great. From a business person's point of view, like it's dead on arrival. But from a mathematician's point of view, it's very nice because you get a few other guarantees as well. You get privacy guarantees, right? You don't know what computation was being done when you're verifying it, which is a nice thing. And this is something that we use in Polkadot. This is something that is used quite a lot in JAM. It's one of the consensus algorithms is based on snark technology for this very reason. We don't use it to scale because using it to scale is so incredibly expensive. Now, optimistic rollups, in reality, it actually should be better called pessimistic rollups because they basically assume that there's a problem, even though there's almost never a problem. But they assume that there is a problem, and they assume because they assume there's a problem, and because they assume it might take a long time for the problem to be discovered, or at least discovered and reported to the blockchain, they take ages to come to a final result, right? To finalize, ages. So on Ethereum, for example, they can take upwards of 7 days. That's 7 days that you're waiting to know that your transaction is actually sort of happened, right? Which makes it useless for a lot of use cases. One important use case is moving between shards, right? Moving between Optimism and Arbitrum, or Arbitrum and ZK AVM, or whatever. You don't want to wait 7 days for that to happen. right? Even on Polkadot, we have to wait like 15 seconds, and it's still too bloody long, right? Like waiting a week is crazy. It's absolute madness. But that's
Yeah.
unfortunately how these things work, because that's the security, that's the design of the security. Now, that's why I call them pessimistic rollups, because they actually are really pessimistic about the security situation. Cynical rollups are not like, they're not idiot rollups, they're not foolish rollups, they're not like foolhardy rollups, right? They're not just gonna like, yeah, it's fine, don't worry, just go ahead and trust that it's true, right? They're
Yeah.
not like cutting any corners, but what they're doing is they're being very shrewd and cynical. They're saying, right, well, we know that there are bad guys out there, we know that there can be profit can be made by being malicious, right? By trying to vote incorrectly, by making things that are incorrect go through as correct,
Mm.
right? By trying to prevent fraud proofs, right? Basically, that the reporting of incorrect behavior, by trying to prevent it from ever being reported or acted upon. So we know that this stuff exists, but how can we make sure that, not regardless that this stuff exists, we can still use these kinds of roll-ups, these kinds of sort of optimistic, in inverted quotes, optimistic style roll-up, pessimistic style roll-ups, but without waiting for so long, right? And that's basically what Elves does. Elves describes a roll-up protocol or a roll-up mechanism that gives us guaranteed security, like proven security, without having to wait for so long. The only time that in Elves you're going to wait for a long time, and therefore in Polkadot and Jam, whenever I say Elves, you can just assume Polkadot and Jam as well. The only time that you'd have to wait for a really long time in Elves is when somebody's going to get slashed, and even then, you're not waiting for a week. You're waiting for most an hour, right? It's like realistically, it's going to be over in a minute, right? So it's being cynical. It's not that we don't think bad guys exist, or we don't think that bad guys want to sort of hack the chain or anything. They're totally accounted for. It's just that we've got a much better way of guaranteeing that security, of ensuring that any bad behavior is reported and acted upon in a very short period of time, and that those who are responsible for it get punished in an accordingly similarly short period of time. And because we can do this, because the expectation of malicious behavior becomes negative, right? Expected profit becomes negative. Basically, you're only on average going to cost yourself money. No one will do it. That's the argument, right? And we can do that without having to wait days and days and days for before we call something final. And in normal functionality, Polkadot reaches finality in, I don't know, 2-3 blocks, so it's like 15 seconds. And in Jam, it's probably going to be even less, because we have a couple of safeguards in Polkadot that were already there for launch, and we haven't removed them because we're quite conservative, but they probably don't need to be there for Jam. So realistically, it's going to be even less, but at most about 15 seconds. And this allows us to do this level of computation, 341 cores, right? Without costing a huge amount. And it's like, if you did 341 cores with zero knowledge proof at the amount of computation we want to do, the costs would be insane. Like we're talking about like equivalent costs to like training an AI model, right? For some period. I haven't worked it out properly yet, but it's like that the amount of GPUs required is insane, and they're required for minutes at a time, right? And if you're talking 341 cores, then it's 341 times minutes times every 6 seconds. We're talking a huge amount of wasted energy, basically, Yeah. And until that 61 million X comes down, then the ZK rollup just isn't going to be a sensible solution. Now, if you're a VC funded moon coin that can afford to throw tens of millions a year at wasted GPU energy, then sure. But these things don't last indefinitely, right? They have their time, and then if they're not economically viable, they will ultimately peter out.
Right.
Whereas cynical rollups are the most cost efficient way of multiplying up computation that we know of blockchain block space computation that we know of. And just to be very specific on the numbers, instead of 60 something million X on just doing it yourself, just doing the computation yourself, it's about 30 to 30, 32, 30 to 30, say 31x times the cost of just doing it yourself, because you have to pay some people to actually do it and check it and stuff, right? That you vaguely expect to be some of whom to be honest, right? So it's not 1x, but it's 31x, right? And that's really good. If you compare it to what compared to 60 something million X, it's really good, right? It's 2 million X better, right? So you're spending 2 million X less money, which means that you can hand validators 2 million X sort of more, so to speak, or more likely it means that you're going to be extracting that much less money, that much less value from the token base, right? From the market. That if we're talking economics, that's what the sort of the corollary is to the fact that the blockchain is cheaper, or it can just do 2 million X more stuff, right? But like this is the corollary, yeah, and it's really, the numbers are not really lying, and it's not that the numbers are gonna. It's not that I think that this 60 plus million X on just doing it yourself is going to stay 60 plus million X, and probably in a year or two we are going to see some reductions, probably orders of magnitude. But is it ever going to get down to 30? No, I don't think so.
Yeah,
I'd be super mega surprised if, at least in the time that I'm in this industry, that it gets below the 30x of just doing it yourself. It would be it would be very surprising.
So one question that comes to mind is about TPS. Like, a lot of blockchains right now say that their TPS is comparable to Visa and stuff. So how JAM affects TPS? Like, will it be?
I mean, I put some TPS. I did a bit of modeling for what we could maybe consider TPS. Honestly, it's becoming less and less relevant as what blockchains can be used for is becoming richer and richer. It's sort of like saying, how many characters can a web page or web server serve on a web page? It doesn't actually matter that much. These days it's actually more about, well, how powerful is the browser environment? How much JavaScript can you run in it? The amount of characters that a web server can deliver to a node is actually, to put on a web page isn't actually so relevant anymore. But I mean, what is Visa? About 50k TPS peak, 20k, 10 to 20k on average. I mean, if you look at the numbers, I think Polkadot, just the relay chain of Polkadot, was sort of Visa level for a bit. Like when the Ordinals thing was going on last Christmas, I think it approached Visa level levels of transactivity. Right? Does it really matter? I don't know. I mean, it's one perspective. For Bitcoin, you can make the argument that it matters. Really, what matters more is how big are the transactions, like how much data is going in, and what is it that the transactions are doing. Like, are they reading past data? Are they doing huge amounts of compute? How much state are they altering? And these are all things that are new, that Visa doesn't do, that Bitcoin doesn't do, that Ethereum does some of, but not everything. And these are new facilities that are going to be very useful to developers when they want to write actual software, not smart contracts, not not fiddly bits of transaction verification script that Bitcoin can do, but like real software, regular software. So I'm like less concerned about the TPS figure. It was always a bit iffy, and now it's just become even more iffy. But I think if you want to look at the grey paper with a lot of caveats, we might see TPS on a service that is specific for doing Bitcoin-y, Visa-y levels of Bitcoin Visa style financial transactions, like balance transfers, of the order of around 1 million. More, I mean, one-ish, but with caveats, right? And there are a lot of design caveats because Jam isn't designed to do specifically balance transfers. It's designed to do general computation with a huge database and be parallelized. And so it's really hard to we kind of have to think, well, okay, if there were a balance transfer sort of Visa service implemented on Jam, how would it be implemented? And therefore, how would Jam's presupposed sort of characteristics, benchmarks that we know of and so forth, how would they map onto the service, and what TPS would it imply? And it's hard to do because we haven't developed Jam yet. We haven't developed a service yet. We haven't really given that much thought to developing a service. So, it's like take the numbers with a pretty heavy pinch of salt. But, if you want a number, then it's, as I've calculated, it's floating around 1 million. Now, a lot of blockchains say, yeah, they can approach these levels of transactivity. I mean, all I'd say to that is just check the benchmarks, run the benchmarks, check the blockchain explorer and check to see, are they actually hitting that? Because a lot of them have said, I mean, I remember that Solana, when it first came out, it was like 700,000 TPS. Like, I'm pretty certain Solana has never done 700,000 transactions in a second. I don't think any testnet for Solana has ever done that. I don't think any node in Solana has ever processed that. Like, it's and it's like, okay, you're in a research paper, you have to write something, sure. And, and then I think it sort of went down to 70k TPS. And I think if you actually look at what the Solana network's actually done, it's a few thousand TPS that it's sort of ran at peak. And if you look at what the transactions are doing, they're doing things like consensus votes. It's not like actual user level transactions. It's not like balance transfers. You got to be quite. You got to question the sort of measurements a little bit and the meanings of words like transactions a little bit. So all I would say is, like, do your own research. Check to see the network. Check to see what user level transactions they've done. Check to see what the transactions are doing. I remember there was an EOS benchmark where they came out and said, oh, it can do Visa level. I don't know, it can do whatever. However many thousand transactions a second. And then it turned out the transactions only were doing 1/2 of a transfer. It was like one of these fan out transactions where it's like there is a single big account that's got, like, I don't know how much in, and it's giving out a little bit to lots of these other accounts, which means you're only actually altering one account balance per transaction, not two, right? And it's like, yeah, well, you're probably going to get quite a big speed up if you only do half of the database operations that you should be doing. Yeah. So it's very, very important to look behind the numbers and check these things. And it's not a crazy ask for to get some number of thousands of TPS these days. 10 years ago, it seemed like it was a substantial challenge. These days, it's not. Computers have gotten faster. Our understanding of blockchain has gotten better. Databases have gotten better. It's like, it's not crazy, right? I think really the difference is is it like based on legacy understanding of blockchain? Like, is it based on Bitcoin basically, or is it based on, is it written from the ground up to be sensible and performant? And then combine that with, is it actually decentralized? Because you can get a lot of throughput improvement if your network is just one node. Yeah, like you can really improve throughput quite a lot. And if your network is 21 nodes in the same data center, like EOS, well, actually, I think EOS just had good connections between them. But if your network is just 21 nodes, you're also going to be able to get a good throughput improvement. If your network is based on having gigabit links and 256 gigs of memory for every node, then and basically only 2 or 3 of the nodes do the vast majority of transaction processing, then again, you're going to get really good throughput. If your network's actually decentralized, it's harder. It's a lot harder, and you have to think a lot more carefully. And this is why Ethereum, with its extremely talented minds, is still finding it so hard to scale after so long. Yeah, because they're actually paying attention to things like decentralization. I mean, somewhat, right? Their approach, I think, does have some issues, but like nonetheless, it's not like they're not kind of selling out on Web3. Yeah, they're not selling out on being decentralized. And whereas a lot of these very hypey, very marketing oriented chains are selling out on some of these principles. And as I say, it's a case of do your own research.
Yeah, I think in 2019, everybody was just talking about TPS. All the new projects. Okay, so one thing I want to ask you, it's a fun part. So, I mean, feel free to not answer if you don't want to, but like, what are your views about meme coins, and have you ever done any kind of Degen stuff ever? Maybe ordinals or NFTs or memes?
Well, actually, in I guess around May or June 2014, I created Gavcoin. It was like a gold coin. If you just type a Gavcoin photo into a Google image search, then you'll find it.
It was on Ethereum, yeah?
Exactly. Yeah, it was one of the first meme coins on Ethereum.
Wait, this was one of the first meme coins? Wow.
It may have been literally the first meme coin on Ethereum, because I wrote it and deployed it using LLL, one of the first languages, the first language, I think.
Yeah, some people are still reading it.
I see there's a Twitter page and everyone's like, there are memes with you, Vitalik, Elon Musk, all of them dancing together. Looks quite
yeah, there's a Twitter page as well.
Yeah. A lot of memes.
I mean, I can't vouch for anything on Twitter, right? But if you search Gavcoin photo into Google image search, you will find you'll find the photo. So that's about as far as I got. I think I did mint an NFT on Polkadot once. I minted the Mamacita cat NFT. That's about as far as my Degen credentials go. No, I'm mostly coding, writing, and a little bit of talking.
But did you ever try like trading, spot trading, or anything, or never?
I'm terrible at that sort of thing. No, I don't.
But have you tried like before?
Yeah. I think he knows because he's trying because
anything to do with any of this stuff. Like pricing things is not my I rely on game theory for anything to do with pricing. Just code it up, let other people figure it out.
You're on JAM Tour right now, and how many countries you have already covered, and what are your plans for India?
So I actually finished the first part of the JAM Tour a few weeks ago. Countries I've covered. Let's have a think. Buenos Aires, Argentina. Berkeley, so the US. Zurich, Switzerland. Then I was in Tokyo, Japan. Seoul, Korea. Hong Kong. I'll leave comment. I won't comment on that one. China and what else? Singapore. So yeah, 7 lectures, and then I kind of did a kind of a sort of capping lecture outside of. They were all at universities, and I did a kind of capping lecture at Brussels in Belgium, and that was the last one. That was at Polkadot Decoded. So I guess 8 in total, and then plans for the next cohort of lectures. They'll probably happen a bit later on in the year, October, November time. IIT is one of the ones that's planned. So that's India, and then also probably a couple more in Europe, possibly one in the US, but yet to be determined. I'm going to be in Asia a bit in September as well, so there's a possibility that there might be one more in Asia, but we'll see.
So have you been to India before, or this is going to be your first time in India?
No, I have. I was in Goa for a conference, INK conference, a few years back.
The best place to be in India.
Yeah, I mean, I don't know. It was pretty nice. I mean, I cook a lot of Indian food actually. So,
Oh, you do?
Yeah.
I do. It's like one of my things.
What's your
I
favorite?
do enjoy cooking.
Indians would
I
love
like-
to hear some. What do you
I
eat?
like boona, so I eat a lot of like chicken boona, lamb boona, but I'll also do like palak paneer. I'll do like
Oh, wow.
bhaji and stuff. Yeah.
That's expert
But,
level, actually.
Yeah,
To hear
I got
chicken
my
paneer.
recipe. Yeah. I got my recipe honed after, I don't know, 15 years of making it. So, but I tell you, it's really hard to find really good quality green chilies in like in the UK. It's pretty easy. Like there's some very good.
Yeah.
You know, you find them basically anywhere. But like I've had a lot of trouble finding them in most of the countries that I've lived in. Like Berlin, pretty hard.
Yeah.
Lisbon, really hard. Malta, really hard. Like Switzerland, not so easy. Like I didn't expect it to be so hard to find some of these ingredients.
So Gavin, thank you so much for taking the time to talk to us today, and it was a pleasure to have you on the channel. We look forward to seeing the future developments of Polkadot and Jam. Thank you so much for the time.
Cool. Thanks a lot, guys. It was a pleasure.
Thank you so much, Gavin. Hope we see you soon. And if you're coming to Singapore, maybe for Token 2049, maybe we'll see you there.
Indeed, I'm planning on being in Singapore for the Asia Decoded, which is the same week.
Nice.
So guys, this was today's AMA session. I hope you found this session useful and you learned something new. If you did, please do hit that like button and do subscribe. We'll see you in the next video. Thank you. Bye-bye.